Hello everyone, welcome to today's lecture. So in the other lecture we started studying about extraction of metals. What are the procedures which are followed for extraction of metals, okay, in metallurgy. We will see metal ore. What do you mean by an ore? Ore is the mineral from which the metal is extracted economically. That means more amount of concentration of the particular metal is present in that mineral. Okay, that means from that mineral we can extract the metal easily and in more amounts. That is said to be an ore. That metal ore, the first process is, the first step is concentration of ore. For concentration of ore there are several methods. We studied about the different methods like Wilfley table, okay, hydraulic method, magnetic separation, froth flotation and leaching. Okay, these are the processes which come under concentration of ore. After concentration of ore, the next step depends upon whether the particular metal which we want to extract is highly reactive, moderately reactive or less reactive. We had studied this in reactivity series. If the metal is highly reactive, then the process followed is electrolysis of the molten ore. The particular different processes which are done, all of them are highly reactive chemical reactions. With the help of those chemical reactions and with the help of electrolysis, you are able to extract the metal. Okay, that is extraction of metal, which is highly reactive. Moderately reactive depends upon which compound form the particular metal is, whether it is in carbonate form or whether it is in sulfide form. If it is in carbonate form, then a process called as calcination is done, that is heating in limited supply of air. Sulfide, if it is a sulfide ore, then the process followed is roasting. Roasting is heating in excess supply of air. Okay, that is the main difference. This is done in limited supply of air and this is done in excess supply of air. While these processes are done, this carbonate will get converted into oxide. Sulfide also will get converted into oxide. That means you will get the oxide of the metal. That oxide of the metal is reduced. That means the oxygen is removed with the help of carbon or by reacting with it with highly reactive metals. That means the metal which is more reactive than the metal which we want. Okay, so if we want a particular metal, you may make it react, make the metal oxide react with some other metal which is more reactive. Then what will happen? Displacement reaction will take place and we will get the metal. So we will get the metal, it is refined and we will get the pure metal. Next is less reactive metals. They are generally sulfide ores. They are heated or the process of roasting, that is heating in excess, that means enough supply of air or oxygen. You will get the metal that is refined and you will get the pure metal. Okay, so this is for highly reactive metals. This is for moderately reactive metals. This is for less reactive metals. We have the extraction process of all these type of metals. Now we'll see one by one. Now we will see the extraction of highly reactive metals. On page number 102, what is the electronic definition of oxidation and reduction? What is oxidation? Oxidation is losing electrons and reduction is gaining electrons. Okay, you may revise it from chapter 3. Now, the metals at the top of the reactivity series are highly reactive. Their reactivity decreases down. For example, potassium, sodium, aluminium are reactive metals. Now we will see sodium, calcium, magnesium. These are highly reactive metals. They are extracted by electrolysis of molten chlorides. Okay, this is an important point from that paragraph. You may mark that paragraph. Now what are the cathode and anode reactions which are taking place during electrolysis of their molten chlorides? This is another 2-mark or 3-mark question. The cathode reaction, that means the reaction which is taking place at the cathode, sodium will react with sodium will add one electron and get converted into Na. As it is gaining electron, it is reduction. At anode, the chlorine ion will get 2 electrons, it will lose 2 electrons, and as it is losing electrons, it is oxidation. These two reactions you have to write if there is a question on the cathode and anode reactions for extraction of sodium chloride. Next is for magnesium chloride. At cathode, magnesium will gain 2 electrons to form magnesium, it is reduction, and chlorine will lose 2 electrons, so it is oxidation. At cathode, calcium will gain 2 electrons to form calcium, chlorine will lose 2 electrons to form chlorine. Okay, so that is oxidation. These are the cathode and anode reactions. Now we may move on to the next topic, that is extraction of aluminium. Extraction of aluminium is a very important topic for the chapter. Aluminium is a metal with atomic number 13. Its electronic configuration is 283. Okay, it is having 3 electrons in its outermost shell, valence shell. What will it do? It will lose those 3 electrons. Okay, and so its valency is 3. Now, the ore of aluminium. What is the ore of aluminium? It is bauxite. The molecular formula is Al2O3.NH2O. This is a frequently asked fill in the blank question. The molecular formula of bauxite. Now this ore contains 30 to 70% of Al2O3. Along with the ore, in the ore there are gangue particles, that means the impurities, sand, silica and iron oxide. Okay. Now, extraction of aluminium takes place in 2 steps, concentration of ore and electrolysis. There are 2 steps, concentration of ore and electrolysis. Concentration of ore is done by 2 processes, Bayer's process or Hall's process. That means for concentration of ore, either Bayer's process is done or Hall's process is done. Now, we will see what is Bayer's process. In Bayer's process, the powdered ore, that means this complete set, okay, that is bauxite, sand, silica, iron oxide, whatever you are getting from the mining industry, it is powdered, okay. That powdered ore is treated with sodium hydroxide solution, that is caustic soda. It is treated with sodium hydroxide solution at 140 to 150 degrees Celsius under high pressure for about 2 to 8 hours. Okay, the conditions are very, very important. During this time, it will react to form sodium aluminate in aqueous form. That means in the form of a solution. You are taking powdered ore, you are adding sodium hydroxide solution to it, then you will get in the solution sodium aluminate. Plus, this silica will also react. You will get sodium silicate also in that water, in that solution. But iron oxide does not react. Iron oxide does not react means it will remain in solid form. That is filtered. What will happen if you filter? This solid form will be removed. That means filtered to remove iron oxide. Now you will get the filtrate. That means the solution in which you are having sodium aluminate, NaAlO2. There is Al which we want. We have to take out that Al from it. Okay. Now that filtrate is treated with water and cooled to 50 degrees Celsius. At this time what will happen? Sodium aluminate will react with water to form sodium hydroxide and aluminium hydroxide. This is in the form of a solution. That means it will be dissolved in water, and this you will get it in the form of a precipitate. That means in the solid form. That means the Al which you wanted from sodium aluminate, you are getting it in the form of AlOH thrice. Again it is in the form of a compound. It is not in the form of Al. But okay, you are getting it in the form of a solid AlOH thrice. That AlOH thrice is filtered Okay, if you filter this solution, you can remove this aluminum hydroxide. That aluminum hydroxide is filtered, washed, dried, and then heated to 1000 degrees Celsius to obtain alumina. That means 2AlOH thrice is heated to get Al2O3 plus 3H2O. Okay, it is heated to obtain Al2O3 plus 3H2O. This will be in the form of a liquid, but this you will get it, okay, that is Al2O3, that is alumina. This is Bayer's process. Okay, so in Bayer's process, you are getting what compound? Al2O3. You are not getting Al because it is the first step, concentration of ore. Now we may move on to the next step, that is Hall's process. The second process, Hall's process. Powdered ore, that means all these you have to powder and you have to add sodium carbonate to it and you have to heat it. When you heat it, the aluminum oxide, this part, it will react with sodium carbonate to form sodium aluminate. Here also sodium aluminate is formed. Here also sodium aluminate is formed in the solution form. Okay, you have to filter it. When you filter it, the other particles will be removed. Then you have to take the filtrate, that means the solution in which NaAlO2 is present. That is warmed and you have to pass carbon dioxide through it. It will react with carbon dioxide to form 2AlOH thrice, that is in the form of a precipitate, and this in the form of a solution. Again, you have got Al in the form of AlOH thrice. That AlOH thrice is filtered, washed, dried, and then heated to 1000 degrees Celsius to obtain alumina. AlOH thrice forming Al2O3 plus 3H2O. Now see the similarities between Hall's process and Bayer's process. First, the differences. Powdered ore is treated with Na2CO3. Powdered ore is treated with NaOH. The filtrate is warmed and passed CO2 with CO2. Here the filtrate is water and cooled to 50 degrees Celsius. Okay, these are the differences. Similarities, in the first step, sodium aluminate you are getting in the form of a solution. Here also you are getting sodium aluminate in the form of a solution. Second, it is filtered for removing impurities. In the third step, here also you are getting aluminum hydroxide precipitate. Here also you are getting aluminum hydroxide precipitate. Fourth step, aluminum hydroxide, filtered, washed, dried, and then heated to obtain alumina. Here also the same. So in both cases, the end product is the same, that is alumina. So here we have finished with the first step for extraction of aluminium, that is concentration of ore. Now we may move on to the next, that is electrolysis. Now the next step is electrolytic reduction of alumina. A very important question, 3 mark or 2 mark question for the cathode and anode reactions, 2 mark question for diagram. It is a very important question, or a give reason question is there. I'll tell you what the give reason question is there. The alumina which we got from the first step, that is concentration of ore. Okay, we got Al2O3. That Al2O3 has to be converted into liquid. It has to be made molten. Okay, it has to be converted into molten state. The temperature required for converting alumina into molten state is 2000 degrees Celsius. Okay, the temperature 2000 degrees Celsius is very high. So we are going to see whether you can decrease that temperature. If you want to decrease that temperature, you may add compounds like cryolite and fluorspar to it. Okay, the compounds of cryolite and fluorspar. The molecular formulas are given in the textbook. You may underline them and learn it. A very important question. Cryolite and fluorspar is added to alumina to reduce the melting temperature to 1000 degrees Celsius. That means the temperature required to melt alumina is 2000. by adding cryolite and fluorspar to it, you can reduce the temperature to 1000 degrees Celsius. This is the give reason question. Okay. Now after that you have to take it in a tank. This is a steel tank. This is the setup for electrolysis. Okay. Now this is a steel tank. These are two rods which are electrodes. Those electrodes, it is connected to the positive terminal, so they are positive, so it is anode. This is connected to the inner lining of the tank. The negative terminal is connected to the inner lining of the tank, so that will be negative, that will be the cathode. That means the inner wall of the tank will be the cathode and this will be the anode. Now you have taken alumina in this plus cryolite and fluorspar. You are going to pass electricity through it. When you pass electricity, you may see it is Al2O3. Al2O3. Okay, when they separate the ionic compounds, so it will form Al3 plus and O2 minus ions. You may note that the valency of Al is 3 and the valency of O is 2. They are written opposite. You have learned this in your 9th standard. So the valency of Al is 3 plus and the valency of O is 2 minus. They will get separated when you pass electricity through it. Okay. What will happen to this O2 minus? Those O2 minus will move towards anode. They will come towards anode and it will lose 4 electrons to form O2. Okay, it will lose 4 electrons to form O2. This O2 will be formed here. That means at the anode. At cathode, what will happen? The Al3 plus will move towards the cathode and accept 3 electrons to form Al, that is aluminium. As it is gaining electron, it is a reduction. You are getting aluminium in the form of a liquid. That aluminium will get collected at the bottom, which is removed from a particular opening of the tank. Okay, so this is electrolysis of alumina. I repeat, you have to melt alumina. To that you have to add cryolite and fluorspar to reduce the melting point. Okay, the melting temperature actually, to reduce the melting temperature. Okay, and it is taken in the steel tank. This is the anode, this is the cathode. This at anode oxygen is getting liberated, at cathode aluminium is getting deposited. That means in the form of pure metal, pure aluminium. Okay, so thus you have got pure aluminium. You have done two processes. One is concentration of ore, the second is electrolytic reduction of alumina. Now this oxygen which reaches the anode is made up of carbon. It is a carbon rod. It will react with carbon to form carbon dioxide, due to which these rods will become smaller and smaller day by day. Okay, after several years it has to be replaced. Why it has to be replaced? Because it is reacted upon by the oxygen which is formed during the reaction. Okay, even this is a give reason question which is very important. So this is about extraction of aluminium. In extraction of aluminium there are two steps: concentration of ore and electrolytic reduction of alumina. Okay, now we'll see the next. Now the next is extraction of moderately reactive metals. It is generally they occur in the form of sulfide or carbonate ores. Okay, or sulfide of or carbonate ores of moderately reactive metals are generally used as ores. The moderately reactive metals include iron, zinc, lead, copper. Okay, these come under moderately reactive metals. There sulfide or carbonate ores are taken and they are heated. They are heated by two processes, either by roasting method or by calcination method. What is roasting? Roasting is heating in excess supply of air, and calcination is heating in limited supply of air. Okay, so this is the main difference. Roasting is heating in excess supply of air, and calcination is heating in limited supply of air. At these times, at the time of roasting, for example, zinc sulfide will react with oxygen to form zinc oxide and sulfur dioxide gas. At the time of calcination, zinc carbonate will undergo decomposition to form zinc oxide and carbon dioxide gas. So, now the second difference between roasting and calcination. For roasting, sulfide ores are used. For calcination, carbonate ores are used. Third difference, for roasting, sulfur dioxide gas is formed. During calcination, carbon dioxide gas is formed. But in both the processes, you are getting oxide of the metal. Okay, so you have got oxide of the metal. In this reaction also you have got zinc oxide. In this reaction also you have got zinc oxide. But you have not got zinc. You want zinc. So next step. It is made to react with carbon, which is a reducing agent. Reducing agent means it will take away that oxygen. So ZnO plus C will form Zn plus CO2. Okay, it will form Zn plus CO2. Now this reaction is not balanced, you may balance it, but this is to show you the displacement reaction or the reduction reaction. Why it is reduction reaction? Because it is taking away the oxygen. So it is the reduction reaction. So either it is made to react with carbon or it is made to react with a more reactive element. Example, MnO2 plus 4Al. In this reaction we want Mn. We have Mn in the form of manganese dioxide. Okay, we are having MnO2. We want to remove that O2. What will we do? We will make it to react with another metal which is more reactive than that. Okay, so here we are making it to react with aluminium. This aluminium is more reactive than Mn. So it will displace Mn and take away that oxygen. So it will form Mn plus Al2O3 plus large amount of heat. Now this is a highly exothermic reaction, that high that we get this metal in liquid form, that is molten form. Okay, in melted form. That means this reaction gives out very high temperature that we get the metal in molten form. Such reactions are called as thermit reactions. One more example is iron oxide. Fe2O3 we have. We want to remove O and take Fe. So it is made to react with aluminium. Again, aluminium is more reactive than Fe. We had learnt the reactivity series. If you want to see, you may see that Al is more reactive than Fe. So Al will displace Fe and take away that O. It will form 2Fe plus Al2O3 plus heat. Okay, even this reaction is highly exothermic, that you get Fe in molten form. Okay, so this is the steps for extraction of moderately reactive metals. In the first step, it is either roasted or calcined. In the next step, it is made to react with a more reactive metal or reduced with carbon. Okay, now you may see on page number 105, there is a do you know diagram which has been given. In that process, they have shown thermit welding process. In that process, the gaps in between the rails, it is being welded by that molten reaction or thermit reaction, sorry. The hot steel from thermic reaction which is formed, it is made to enter into that mold, enter into that gap with the help of that mold, and it is welded. Okay, now we may see the third one. Now this is about extraction of less reactive metals. Examples of exactly less reactive metals like gold, silver, platinum, they are available in free form. but there are some metals which are available in compound form. For example, copper. Okay, copper could be considered under moderately reactive also and less reactive also. In case of copper sulfide, that is Cu2S, this is just heated. They don't have to undergo different processes, but Cu2S, if it is heated, it will react with oxygen to form 2Cu2O plus 2SO2 gas. That 2Cu2O, if it is further heated, then it will form copper. Okay, you will get copper. The reactions are very, very important. 3-mark question it is about extraction of copper. Okay, next is about mercury. Mercury, the ore is cinnabar. This is an objective question. The ore of mercury is cinnabar. It is HGS. Okay, 2HGS, if it is heated, it will react with oxygen to form HgO and SO2. This HgO, if it is further heated, it will form Hg, that is mercury. Now, in these processes, for extraction of moderately reactive metals and extraction of less reactive metals, the metals which you get might contain some amount of impurities. So, it is further purified by the electrolytic refining method. Okay, that is the last point, that is refining of metals. So in refining of metal, which method is used? Electrolysis method is used. So today we studied about extraction of metals: highly reactive, moderately reactive and less reactive. For highly reactive, we studied about aluminium. For moderately reactive, we studied about zinc. For less reactive, we studied about copper and mercury. This is a very important part of the question of the chapter. There are several questions which are asked from this part. You may read the textbook and ask doubts if you are having any. Okay, thank you.